Hey guys, today we are finally starting something new in this chapter. We're going to be looking at a different form of the equation of a line. This one is called slope point form, and as the name suggests, it involves slope and a point of the line. Okay, so this is lesson 6.5, slope point form. This is the equation of the line in slope point form. So y minus y1 equals m times x minus x1. In this case, the m still represents slope. The x and the y still represent any coordinate on the line, and we still keep them as variables. So the x and y stay as variables, unless we're trying to solve something. But if we're just writing the equation of the line, the x and the y are going to stay as x and y. The part that's different is this x1 and y1. X1 and y1 are also a coordinate on the line, but we actually write in the numbers of that coordinate. So the x1 and the y1 will be replaced with numbers. So let's look at an example of what this would actually look like. Okay, so in this example, I have said that line A has a slope of -5 and goes through the point 3, -4. So I'll start by just writing out my general equation. So y minus y1 equals m times x minus x1. And then again, our slope is going to get plugged in where the m is, and our x and y coordinate will go where the x1 and the y1 are. So what this will look like is y minus our y coordinate, which is -4, equals our slope of -5 times x minus our x value, which is 3. Now, the one thing that you are not allowed to have is this, two negative signs beside each other. You should never have that in an equation. An equation is never simplified if you have two minus signs beside each other. If you are subtracting a negative number, those two minuses come together to make a plus sign. Okay, so what this really means is y plus 4 equals -5 x minus 3. That would be the actual slope point form equation for this line. So what you might notice, and what is a rule when you're doing slope point form, is that the symbols of the x1 and the y1 in your equation are opposite of what they are in the actual point. So in the point, my x value was positive, now it is negative. In my point, my y value was negative, now it's positive. So that is a general rule that when you plug in a coordinate into the slope point form equation of a line, the symbols of your coordinate, the signs in front of your coordinate, will change. Okay, so I've just written out that rule. The signs of the x and y in the coordinate will change when they are put into the slope point form equation. Okay, that's really the only tricky thing about the slope point form equation. That's all I have to say about that. Okay, another example, which is very similar to the first, says line B goes through -1, 2, and 7, 14. Write the equation in slope point form. So obviously, to use slope point form, we need slope. So if you're not given slope, you do need to find that first. But we, of course, just do y2 minus y1 over x2 minus x1. So 14 minus 2 over 7 minus -1. So 14 minus 2 is 12, and 7 take away -1 is 8. Both of those are divisible by 4. If I divide 12 by 4, I get 3. If I divide 8 by 4, I get 2, which means my slope is 3/2. And then to write that as an equation, I'm going to have y minus my y variable, so 2, equals my slope, 3/2, and then x minus my x variable. But remember, when I subtract a negative number, it really becomes positive. So that is what the equation of a line would look like. So I have my slope, I have my x and y coordinate, and their signs are backwards from what they were in the point. I could also write it using the other point, and it would look like that. Once again, same slope, using my other xy coordinate, and again, changing their signs. Okay, both of those equations are equally valid for that line. Okay, the last thing that we're going to look at is how to convert slope point form to slope intercept form. Just super important to know how to do. So we're going to start with an equation in slope point form. Let's see. Okay, let's say we have an equation like this, which has a slope of 3/2 and the coordinate -4, +2 would be the coordinate. To convert this into slope intercept form, the first thing you want to do if you have a fraction for your slope is get rid of the fraction. In order to do that, you have to multiply by the denominator. Sorry, I really struggled to spell that. So the way that this works is I'm going to multiply by 2, because that's the denominator of my fraction, and that will cancel out that denominator. But when I do that, I also have to take the entire other side of the equation, where the y minus 2 is, and multiply that whole thing by the denominator. What I'm then left with is 2 times y minus 2 equals, and on this side I just have the 3 left in front here, so 3x plus 4. Then I need to multiply the 2 into the brackets on the left side and the 3 into the brackets on the right side. So that gives me 2y minus 4 equals 3x plus 12. I'm then going to start gathering my like terms, and because I want to get into slope intercept form, which is y equals mx plus b, I want the y to be alone on the left side here. So I'm going to move the minus 4 away from it. So I will add 4 to cancel that out, which means I must add 4 to the other side. That leaves me with 2y equals 3x plus 16. And then my last step is to totally isolate that y, which means get the 2 away from it. Because right now it is 2 times y, I need to divide by 2 to get it away from the y. When I do that, I have to divide both of these terms by 2. So divide by 2 and divide by 2. That leaves me with y equals 3/2x plus 8. And now it is in y equals mx plus b form. Remember, you always want to keep your m value as a fraction. And when you do this, the fraction that you have for your m value in your final answer should be the same fraction you started with for your m value. Okay? So that's it. That is how you convert slope point form to slope intercept form. Don't forget, when you multiply by 2 here, you have to multiply both terms on the other side by 2. And when I divide by 2 here, I have to divide both terms on this side by 2. When you're multiplying and dividing, you must do it to all of the terms on the other side. However, when I added this 4, I didn't have to add it to both terms. When you're subtracting and adding, you only do that to the like terms, so the 12 and the 4. Okay, let me know if you have any other questions.